previous unit, we created a polygon of constraints by mapping out a number of lines on the graph. Now we want to find the vertices, or the place where each of the sets of two lines intersect. That gives us an x and y intercept of those two lines, which are the vertex or vertices, the corners, of the polygon of constraints. There are three steps to finding the vertices. First, we label each vertex of the polygon of constraints, usually A, B, C, D, and then we identify the two lines that go through each vertex and change the inequalities to equals, just so we can work with them more easily. Then we solve the system. If the lines intersect to form the vertex are two equations with each including both variables, then we use the comparison method. Or if we have one equation with both variables and one equation with only one variable, then we can use the substitution method. If we have two equations, each including only one variable, those give us the two x and y coordinates that we're looking for. For example, determine the vertices of the polygon of constraints given the following scenario. A bag contains red and blue marbles. A bag contains a maximum of 6 marbles. The bag contains a minimum of 2 marbles. There are at least as many red marbles as blue marbles, and the bag contains at most 5 red marbles. We're going to follow the steps the same as we've been doing up until this point in the unit. We start off by defining our two variables. So we let x equal the number of red marbles, and then we let y equal the number of blue marbles. Then we need to take each of the statements and turn those into mathematical inequalities that we can begin working with. So the bag contains a maximum of 6 marbles. So that's x plus y is less than or equal to 6. The next statement says the bag contains a minimum of 2 marbles. So that's x plus y is greater than or equal to 2. There are at least as many red marbles as blue marbles. So that means x has to be greater than or equal to y. So there's at least as many, so it could be equal or it could be more. And then the final statement says the bag contains at most 5 red marbles. So that means x has to be less than or equal to 5. Now there are also two other statements that we always have to keep in mind. In this case, we can't have less than 0 either red or blue marbles. We can't have a negative number of marbles. So that means that x has to be greater than or equal to 0, and y also has to be greater than or equal to 0. Now in order to graph them, we always want our equations to be in the y equals ax plus b format. So let's go ahead and get all of our statements into that form so that we can work with them. X plus y less than or equal to 6, we need to rearrange that to be y less than or equal to negative x plus 6. That's using the algebra skills that we already have developed. The next line, x plus y greater than or equal to 2, we're going to rearrange that one to be y greater than or equal to negative x plus 2. Then x greater than or equal to y can be rearranged into y less than or equal to x. And then with our x greater than or equal to 0 and y greater than or equal to 0, we know how to graph those already. So let's see how this all works out when we start to graph it. Let's take the first line of y less than or equal to negative x plus 6. So we know we start off by setting the y-intercept at 6, and then using the slope of negative 1 to go down 1 and over 1, and then connecting those two dots to get our first equation. Because it's less than or equal to, the shading for that one would go down below the line. So we can draw some arrows indicating the shading is below that line. Next, we look at our second equation of y greater than or equal to negative x plus 2. Similar approach, we plot 2 on our y-intercept, and then use the same negative 1 slope to go down 1 and over 1, and again connect those two dots with a straight line. We should have arrows on the ends of both of our lines. And then in this case, the arrows indicating the shading from this line go up because it's y greater than or equal to negative x plus 2. Then we look at our third line, third equation, y less than or equal to x. And for that, we know we've got a slope of positive 1 and a b value of 0, right? There's nothing there. So we can go ahead and start at the origin. and go up 1 over 1 to get a second point, and again connect those lines. In all three cases, we were using a solid line to connect the dots because each of them had an equal to as part of their inequality. Also with this line, we look at it and said it's y less than or equal to x, so it's the space below this line. Now we look at our next three inequalities, x less than or equal to 5. So we find 5 on the x-axis, draw a vertical line, and the shading, because it's x less than or equal to 5, the shading goes to the left on that line. Next one, x greater than or equal to 0, so that is the y-axis. And y greater than or equal to 0 is the x-axis, so it has to be above that. And if we look very carefully at where everything intercepts, where all those shaded areas connect, we could outline it here in red. This is the area that's included, so we could go ahead and then shade in that area. So that's the solution to all of these inequalities. Now the next step is to go ahead and find the vertices. The next thing we're going to do is label each of the vertices. We've got A, B, C, D, and E. So we've now identified the polygon of constraints and we labeled all of the vertices. Now we need to find the coordinates of each of those vertices. In this case where we've graphed it and it looks like the numbers are working out nicely, we could potentially read those vertices off the graph, but we can't always be sure that they're going to give us exact nice numbers that turn out to be nice even coordinates like 3, 3. So we need to be able to solve it algebraically. If we go ahead and look at vertex A, we can see that it's the intersection of two lines. It's the intersection of y greater than or equal to x and this line here, which is y greater than or equal to negative x plus 2. So now what we need to do in order to find that vertex of that polygon of constraints is to simply identify where those two lines intersect. To do that, we'll use one of the methods that we've already been using to solve systems of equations. So the first thing we do is turn each of these into equations. So fairly straightforward. We simply eliminate the inequality sign and we end up with y equal to negative x plus 2 and y equal to x. Now it's fairly easy to see that we were able to do a substitution because we've got y equal to x. We can simply plug that x into this equation. So we take our y equal to negative x plus 2. Then we take this equation, y equal to x, and that allows us to substitute in here an x in place of the y. So we can say x is equal to negative x plus 2. Now we need to solve for x using our algebra. We've got 2x is equal to 2, or x is equal to 1. Once we've got a value for x, now we can substitute back into one of our equations. In this case, the easiest one would be the y equals x, and we can come to the conclusion that y is also then equal to 1. So the vertex A is in fact 1, 1. Let's go ahead and look at the next vertex, vertex B. The two lines that go through vertex B are x greater than or equal to y and y less than or equal to negative x plus 6. So let's go ahead now and solve for that system of equations as well. So we follow the same approach. We take the two inequalities and we turn them into equations. Y equal to negative x plus 6 and y equal to x. Now again, we can see that it's fairly straightforward to do a substitution. We've got y equal to negative x plus 6. We're going to take this y equal to x, and that allows us to replace the y with an x. So we're taking this y and replacing it with this y, which we've said is equal to x. So now we can say x is equal to negative x plus 6, solving for x, we have x equal to 3. We can then substitute x equal to 3 back into this equation and get the y value, which in this case is very simply 3. So therefore vertex B is 3, 3. Back to our original diagram again, let's look at vertex C. Vertex C is the intersection of two lines again, y less than or equal to negative x plus 6, and the vertical line x less than or equal to 5. So let's go ahead and solve for those two. Following the same process, the first thing we're going to do is convert the two lines into equations. So y equal to negative x plus 6 and x equal to 5. Again, we're in a situation where we can do a direct substitution. This time we're substituting a constant value in for x. So we take y equal to negative x plus 6. We can substitute in this 5 for the x value. Once we've got our value that says y equals 1, we can then substitute that into one of the equations to solve for x. So we'll go ahead and substitute back into the original equation to find the y value. Y equals negative x plus 6. We put 1 in for the y, negative x plus 6, and we solve for x. X is equal to 5. Therefore, the vertex C is 5, 1. Returning to our graph, we look at vertex D, and again we see that it's the intersection of the x-axis, which its equation is y equals 0, and the vertical line that we have, which we identified previously as x less than or equal to 5. Let's go ahead and find the solution for those two lines. So in this case, we've got two equations. Each of them only has one variable. If we go ahead and convert them into equations, y equals 0 and x equals 5, we can see that we've immediately got a set of coordinates. So vertex D is very clearly simply 5, 0. Y is 0 and x is 5. That information is pretty much given to us. Let's go back and look at the final vertex point E. E is again the intersection of two lines, the y greater than or equal to negative x plus 2, and the x-axis, which is y equals 0. Again, the method we choose to solve this is very clearly substitution, because we've already got y equal to 0. So all we have to do is take the first equation, y equals negative x plus 2, substitute in y equals 0, so it replaces this y with a 0. We've got 0 equals negative x plus 2, or when we solve algebraically, x is equal to 2. So the vertex E is 2, 0. So let's go and recap that process. First, we wrote out all of our constraints. Then for the ones that weren't in the y equals ax plus b format, we formatted them into that form. Then we graphed each of the lines and found the polygon of constraints. Once we had the polygon of constraints, we labeled each of the vertices. Then we found the point of intersection of the two lines that make up those vertices to get the vertex points. Now, go ahead and try the next question yourself, and once you've done that, come back and check the next video to see the answer to see whether your solution matches up. In this question, determine the vertices of the polygon of constraints given the following scenario. John loves his stuffed animals. His collection has stuffed bears and stuffed dinosaurs. John has a maximum of 10 stuffed animals. John has less than or equal to 4 bears, and John has at least one more dinosaur than bear. So we start off with our two variable definitions. let x be the number of bears, and let y be the number of dinosaurs, or dinos. So John has a maximum of 10 stuffed animals. So that means x plus y has to be less than or equal to 10. Then John has less than or equal to 4 bears. So our bears are x, and that has to be less than or equal to 4. And finally, John has at least one more dinosaur than bear. So our rule there is generally we look for whichever one we think is the biggest, so is it dinosaurs or bears, and then we add the modifier onto the other variable. So he has at least one more dinosaur than bears, so we know he has more dinosaurs, so we're going to add the modifier onto the bears. So we take our dinosaurs and our bears, and we add 1 to the bears, and he has at least that many, so it's greater than or equal to. So y greater than or equal to x plus 1. So that's our set of 3 constraints. Plus, we always need to take into account the fact that our x and y axis, in this case again, we can't have negative numbers of animals. So as a result, we also have to say that x has to be greater than or equal to 0, and y is also greater than or equal to 0. So we've got a full set of 5 constraints that we need to take into account. Let's go ahead now and look at graphing those. The next step we need to do is to get all of the equations into the y equals ax plus b format. In this case, the only one we need to worry about is the x plus y less than or equal to 10. So we know we can rearrange that into y less than or equal to negative x plus 10. Now we'll go ahead and graph that. Put 10 on the axis. Our slope is negative 1, so we go down 1 and over 1. And connect those points. Arrows on the end. And then look at the inequality. Since it's less than, it means the arrows, the shading area, is going to be below the line. Now we take the next equation, or the next inequality, x less than or equal to 4. There's 4 on our axis. Go ahead and draw a vertical line from there. Arrows on the end. And because x is less than, it means the air shading is going to the left. Look at the next equation, y greater than or equal to x plus 1. So that starts at 1 on the y-axis, and it's got a slope of positive 1, so it's up 1 and over 1. Go ahead and connect those points. And again, the shading. In this case, y is greater than or equal to, so again, it is above the line space. Then our 2 constraints, y greater than or equal to 0 and x greater than or equal to 0, mean that we're above the x-axis and to the right of the y-axis. That helps us define the space that we're going to be working with, and we can see if we look at all the places where those overlap, it's this space in here, sort of the triangle with the tip cut off it. So we can mark off that space. Draw an outline around it just to help highlight the area that we're talking about. So that's the area, and we'll go ahead and just do a little bit of shading here to show you the area that we mean. Now our next step is to go ahead and label each of the vertices. Start here, we'll say that's A, B, C, and D. Now we want to find the coordinates, the x and y coordinates, of each of those points. To do that, we're going to look for the intersection of sets of lines. So here we've got the y-axis, which we know is x equals 0, and this other line here, one of the first lines that we graphed, which is y less than or equal to negative x plus 10. Let's go ahead and solve that. We take our 2 inequalities, turn them into equations, and then solve. Again, in this case, it looks like substitution is an easy methodology for solving them. So we take our y equal to negative x plus 10. We can take our x equal to 0 and substitute that in. So y is equal to 0 plus 10, so y is equal to 10. That gives us the coordinates of the vertex for A. Is 0, 10. Now, looking at vertex B, we see that it's the intersection of that same line, y less than or equal to negative x plus 10, and the line x less than or equal to 4. So let's go ahead and solve that. Once again, we've turned the inequalities into equations, and we can see once again as well that substitution is the appropriate method for solving. So we take y equal to negative x plus 10, and we can replace the x with a 4. So we've got y equal to negative 4, y equal to negative 4 plus 10, therefore y equals 6. So the vertex B is 4, 6. Back to our diagram. Let's look at point C. Vertex C is the intersection of that same line x less than or equal to 4, and the third equation y greater than or equal to x plus 1. Let's go ahead and solve that. Again, we convert the two inequalities into equations, and again we can use substitution as the appropriate method to solve. So we've got y equal to x plus 1, and this time we're going to again take the 4 and sub it in for x. So we get y equal to 4 plus 1, or y equals 5. So the vertex C is 4, 5. Finally, we look to our last vertex, which is vertex D. It's going to be the intersection of the y-axis, which is x equals 0, and the line y greater than or equal to x plus 1. Let's go ahead and solve that. We've converted both our inequalities into equations, and again we can use substitution as the appropriate method to solve. So y equal to x plus 1. This time we'll substitute the 0 in for the x, which gives us y equal to 1. Therefore, the vertex D is 0, 1. Finally, I think if I wanted to get full marks and keep my teacher particularly happy, I would, whenever I'm writing a test, make sure I summed everything up at the end of the question to show that the vertices of the polygon of constraints are, and then list out all of the vertices that you found.